Hello, beautiful people, and welcome. In today's video, we are going to be talking about Chapter 10 for Integrated Math 1. Let's go and get started. For questions number 1, or the questions on number 1, this is going to ask for English and your math. So English answers are going to be what do you have and what does that mean? And the mathematical solution is going to be taking your English, creating an equation, and then solving that equation. So, for example, for your English, here we have your inside thinking bubble, right? Here's your inside. So we notice that our two angles are not on the inside. So these are called exterior angles. Now, because they are both on the outside, exterior, but on the opposite side of the transversal, these are alternate angles as well. So these are called alternate, and I'm going to abbreviate alternate exterior angles. Okay, what does that mean? That means they're on the opposite of the transversal, but also on the outside of the parallel lines, which then means that they are congruent. And congruent means they are equal in measure. So we're going to take that congruent equal in measure to set up our equation. So we got 80 degrees is equal to 14x minus 4, dotted line for balance. We're going to then subtract, just kidding, we're going to add 4 to both sides. Remove the 4, bring down the 14x. And we got 80 plus 4, which is 84. And then we'll divide by 14. X is then equal to 84 divided by 14. I get 6. All right, let's go again. Here's your inside thinking bubble. Notice how we have one angle on the inside and one angle on the outside, but they are on the same side of the transversal. This is called corresponding angles because their location is the same. So if I was to cover the bottom, notice how this is kind of like the bottom left. And if I was to cover the top, this is also the bottom left. So location is the same. So we have corresponding angles. Corresponding angles means their location is the same. And that means they are also congruent. And what does congruent mean? Congruent means equal in measure. Take your congruent equal in measure. Let's go ahead and set up our equation. I'll do 12x minus 5 is equal to 5 plus 10x. Dotted line for balance, and let's go ahead and solve. I'm going to go ahead and move the 10x first. You don't have to move this first. It really doesn't matter as long as you solve correctly. I get 2x, bring down the minus 5. I'm going to add 5 to both sides. Bring down the 2x. Dotted line for balance. And we get 10 here. Dividing by 2, dividing by 2. X is then equal to 5. Moving on to the next relationship, let's go ahead and do our circle, or I guess not a circle, but a thinking bubble. Notice how we have both angles on the inside of the parallel lines. Notice how they are still on the opposite side of the transversal. So opposite means alternate. And again, I abbreviate alternate. And now because they are on the inside of the thinking bubble, these are interior angles. I abbreviate as int. And then we have angles. Alternate interior angles. Okay, what does that mean? That means we had opposite of the transversal, but the same side inside. So not on the same side, but on the opposite side inside of the transversal. What that means is they're also congruent. And congruent means equal in measure. So we're going to go ahead and bring that up. Congruent means equal in measure, so we're going to set these equal to each other. I'm going to subtract 8, dotted line for balance. 80 minus 8 is 72. Bring down the 9 times x. Divide by 9. Divide by 9. X is then equal to 8. Okay. Moving on to our next question. Okay, again, here's our inside thinking bubble. So notice how the two angles are not on the inside. Both, I guess one of them is, but both of them are not. Also notice that the location is not the same, right? They're kind of like across from each other. So when we have angles across from each other, these are called vertical angles. And vertical angles are across from each other diagonally. And because they are across from each other diagonally, we are congruent. And since we are congruent, we are equal in measure. Equal in measure means we're going to set up our equation. This is a one-step equation. Brings us back to the beginning of the semester, or not even the semester, of the school year. So let's go ahead and subtract 101. Bring down the x. And 98 minus 101 is -3. Now, it is okay for x to be -3 because x is not a measurement of an angle. X is a variable that represents an unknown number. So if x was an unknown angle, then angles can't be negative. Let's move on here. Again, here's our inside thinking bubble. Notice that we have both of them on top, and they're right next to each other. So what these are is, if we draw this little arc here, these are angles that form a line. These angles are called linear pair. Pair means that there's two of them, and these two angles make up a line. Linear pair are two angles that form a line. And because they form a line, they are supplementary. And supplementary means that the angles add to equal 180 degrees. So a different setup now, because we no longer have congruent angles. These are supplementary. So that means we're going to take both angles, x plus 134 and x plus 54, and we're going to set these angles equal to 180 degrees when we add them. Dotted line for balance. Drop your parentheses, and let's go ahead and combine like terms. So we have an x and an x. That gives us two x's. We need to add 134 plus 54, which gives us 188 positive. I'm going to subtract 188 on both sides. That gives me a -8. Bring down the 2x. Dotted line for balance. Divide by 2. Divide by 2. Oh, I don't know why I divided by negative. That's wrong. It should be a +2. So we have x is equal to a -4. Okay, last one on this page. Here's your thinking bubble for the inside of the parallel lines. Notice how we have both of the angles on the inside, and notice how both of the angles are on the same side of the transversal and on the inside. So these have a special name. These are called consecutive interior angles. And consecutive interior means they're on the same side inside. So same side of the transversal inside the parallel lines, which means they are supplementary. which means that the angles add to equal 180 degrees. Again, so that's what we're going to use. That English is what we're going to use for our setup. That means the angle, so x plus 134, added to the other angle, x plus 56, equals to 180 degrees. Dotted line for balance. Drop your parentheses. Let's combine like terms. X and x gives us 2x's. 134 plus 56 is 190, positive. I'm going to subtract 190 on both sides, bringing down the 2x. Divide by 2. Ooh, that's wrong. Let's go ahead and fix that. 180 minus 190 is a negative 10. Now I get to divide by 2. X is equal to a negative 5. Okay, moving on. Okay, for each of the following questions, state the English answer, solve for x, solve for both angle measures. Okay, so for this one, it wants kind of like 3 different things. So we're going to need to write out our English, we're going to need to write out our math, solve for x, and then use x to solve for these angle measurements. I'm going to go ahead and go a little bit faster now. We have inside on opposite sides. So that means we have alternate interior angles. That means they are inside, so opposite of the transversal, inside of the parallel lines. That means they are congruent, which means they are equal in measure. Equal in measure, let's do our setup to solve for x. Dotted line for balance, I'm going to start by subtracting 11x. Careful here because you do end up with negative 1x. Bring down the negative 9. Divide by negative 1, divide by negative 1, x is equal to positive 9. I'm going to put this in a thinking bubble because yes, we do want to solve for x. That is something that they want. But also we want to use that x to solve for the angle measurements. So here we have 10x as one angle. So 10 times 9 is 90. So we have 90 degrees here. Now, you can solve for the other one. You can absolutely just plug in x, but you don't really need to because of this congruent equal in measure. Since we know that these are going to be equal in measure, immediately that one also needs to be 90 degrees. But if you don't catch that on the test and you would like to plug things in, that is also okay, and that will also give you 90 degrees. Moving on. Again, let's do this one quickly. Here's your inside. So the angles are not on the inside, they are on the outside, and they're on opposite sides of the transversal. So these are alternate exterior angles. That means they are on opposite sides of the transversal, and they are on the outside of the parallel lines. And what does that mean? That means that they are congruent. And if they are congruent, they are equal in measure. Equal in measure means that our setup is going to be 15x is equal to 14x plus 6. Dotted line for balance, I'm going to subtract 14x. Bringing down the positive 6, here I have just 1x positive. And so x is equal to 6. You can put a box around it or a thinking bubble, that's fine. Understand that this is not the only answer. You do need to find the angle measurements. For the angle measurements, again, you can do one or you can do both. Because we have congruent equal in measure, both of them are going to be equal in measure. So I'm going to do 15 times 6 to do this one is equal to, no idea. Let's go ahead and use a calculator. 15 times 6 is 90 degrees. It is not always 90, it just happens to be 90. So we know that the other one's going to be 90 as well because of congruent, equal in measure. Moving on to the bottom one. Notice how we have both of the angles on the inside of the parallel lines and they are on the same side of the transversal. So that means we have consecutive, interior angles. So that means same side of the transversal and on the inside of the parallel lines. These angles are supplementary. And if they are supplementary, that means the angles add to equal 180 degrees. So what that means is we're going to take our two angles, we're going to add them and set them equal to 180 degrees. Dotted line for balance, let's drop our parentheses. Combine like terms, 10x plus 8x, that's 18x. 7 take away 7, that's just 0. If you want to write 0, you can. You don't have to because you're just going to remove it anyways. It's 0. Divide by 18, divide by 18. X is equal to 10. Again, you're not done here. We do need our angle measurements. Now, this one is not congruent. Okay, these are not equal in measure. So the easiest way to do this one is to go ahead and solve for both by plugging in 10 for X. And then just to show you, you can just type this into the calculator exactly how you see it. Get your angle measurement here. 107 is this one. And then the other one is 73 degrees. And together, they need to add up to 180. So quick check is 107 plus 73 should give us 180, and it does. Moving on to question number 3. For the following questions, find the measure of the indicated angle that makes lines U and V parallel. State the converse that makes the lines parallel. So you have to be careful here. So this goes back to when we were doing proofs. And when we were doing proofs, we stated that there are theorems when we have parallel lines and converse when we're trying to prove parallel lines. So that means that the converse, the word converse, is going to be at the end of all of your answers in this section, okay, in these questions in this section. So let's go ahead and take a look at what we have. Here's our little interior thinking bubble, our inside thinking bubble. Notice that these angles are on opposite sides of the transversal. And they are both on the inside. So these are alternate, interior, angle, and we are trying to prove parallel lines. So that means that we are going to write the word converse. Okay. Now it's also asking us to find the measure. Well, what does it mean for alternate interior angles? Alternate interior angles are congruent. So to make these lines U and V parallel, this angle right here also needs to be equal in measure. Next one, here's our inside thinking bubble. These are on the same side of the transversal, both on the inside. This is called consecutive. Interior angles. Now again, because we're trying to make parallel lines, we got to write the word converse. Now, consecutive interior angles are supplementary. Oops, let's squeeze in another P. Supplementary means that we're going to take 130 plus something, and that's going to equal to 180 degrees. I'm going to quickly subtract 130, subtract 130. That means our unknown angle, you can call it X if you'd like, is going to be 50 degrees. So what makes U and V parallel? Well, if this angle is 50 degrees, then sure, U and V will be parallel based off of the consecutive interior angle converse. Make sure the word converse is there for these questions. Name the relationship used. Notice that we have the same location. So that means these are corresponding angles. And again, because we are trying to prove parallel lines, we are going to write the word converse. Corresponding angles are congruent. And since they are congruent, they are equal in measure. So what makes U and V parallel? Well, if this question mark, if this angle is also 102, that means we have parallel lines. Okay, moving on. It looks like we're doing the exact same thing. For the following questions, find the value of x that makes parallel lines. Now remember, this is also state the converse. We also want to make parallel lines. Since we want parallel lines, the word converse is going to be in our answer. They do want the value of x, so we're basically doing the same thing except we're using the word converse to do it. So let's do our little inside. So these are not interior angles, these are exterior angles, and they are on opposite sides of the transversal. So we got alternate exterior angle. And we're trying to get parallel lines, so the word converse is here. Converse for the alternate interior angle, these are congruent. Congruent means equal in measure, so we're going to set these two here. Equal, solving for x. Mathematically, we're kind of doing the same thing as we did on page 1 and page 2, but we're calling it something else because our goal, our objective has changed. We do not have parallel lines, we need parallel lines, so we are calling it something else. We get 65 plus 7, and that is 72. We're going to divide by 8, divide by 8. X is then equal to 9. Moving on to the next one. Here's our interior thinking bubble. Okay, so these are both on the inside on the same side of the transversal. These are consecutive. Interior angles. And again, we're trying to prove parallel lines, so we got to write the word converse. Consecutive interior angles are supplementary. So we're going to say 49x plus 2 is adding to 39x plus 2, and that's equal to 180 degrees. Drop the parentheses, combine like terms, and solve for x. Dotted line for balance. We're going to be combining 39x's and 49x's. That gives me 88x's. And then 2 plus 2 is 4. Oops. I'm going to subtract 4, bring down the 88 times x, 180 minus 4, that gives me 176, divide by 88, and I'm going to write my answer here, x is equal to 2. Okay, moving on. Name the relationship. Let's go ahead and figure out what kind of relationship we have. Notice that these are both on the same side of the transversal, however, their location is the same. So they're not both exterior, they're not both interior, one's inside, one's outside, but the location is the same. That means we have corresponding angles. Okay, we are trying to prove parallel lines, so we write the word converse. Be careful on the test. You have to either write the word theorem or you have to write the word converse. If you don't, points will be removed. Otherwise, I don't know if you understand the difference between a theorem and a converse. All right, what do we got? We got congruent. Congruent means equal in measure. So let's go ahead and make sure these are equal by subtracting 89 on both sides. X is then equal to negative 9. Okay, next one. Both are on the interior, so both are on the inside, but they are on opposite sides of the transversal. So that means we have alternate interior angles. And we are trying to make parallel lines, so we are going to write the word converse. Alternate interior angles are congruent. So that means these two are going to be set equal to each other, and we're going to find out what value of x makes these congruent. Dotted line for balance, I will be subtracting 3, bringing down the 17 times x. 105 minus 3 is 102. Divide by 17, divide by 17. X is then equal to 102 divided by 17 is 6. Again, please make sure to understand when to write the word converse and when to write the word theorem. Okay, moving on next. Find the distance from point A, here's point A, to BD line. So line BD, where's BD? BD is here. So we did a couple of these in class, and there's 1, 2, 3, I want to say maybe 5 steps for something like this. With this one, you're going to have a 6th step because they're not giving you a line. So we kind of have to write this out on our own. So the point that they're giving us is A at negative 3, 3. The line you have to write out on your own as y equals mx plus b. To do that, you're going to, if you want to bring highlighters on the test, you can. But to do that, you're going to take a look at your y-axis, and you're going to find out where this y-intercept is, and that is at negative 2. So your b value is now going to be at negative 2. You're going to have your x, you're going to have your y. Next, you're going to find out your slope, which is up 1 over 1, up 1 over 1, up 1 over 1. And so we have y equals 1. You can do 1 over 1, or you can do just 1, or you can just do x, it doesn't matter. And so we have our line, and we have our point. Okay, this is in thinking bubbles. This is not at all your answer. We have to do a lot more. Okay. Now, what's really cool about this question is that the point of intersection is already given to you here. So technically, we don't even need that. So I wanted to point out that we can draw a line for it, but I'm going to highlight this in a different color here. And I'm going to highlight this in a different color or make it stand out here. We already know what the point of intersection is. We don't have to do a perpendicular slope. So I'm going to do this kind of like in 2 different ways. If we were to just be given a point and a line, so then we would have to find the perpendicular slope. And that would be from this 1, which is positive, would be negative 1 over 1 because we would flip the fraction. We would then go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and we find that this is the point of intersection. For this specific example, you didn't need to do that because it gave you a right angle. You already know what the point of intersection is. With our 2 points, we got point 1, which is negative 3, 3. We have our point 2, which is our point of intersection, and that is C at 1, negative 1. And what are we trying to find? We're trying to find distance. So we're going to write out our distance formula. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Take the square root. Label your points, x1, y1, x2, y2. So y2, just kidding, x2 is 1. x1 is negative 3. Careful here with double negatives. y2 is negative 1. y1 is a 3. Now what you're going to do is you're going to type all of that inside into your calculator. Do not do anything with the square root. 1 minus negative 3, close it, square it, plus open negative 1 minus 3, close it, square it. We just want the inside. and that gives us 32. Now, this here is still inside of the radical, still inside of the square root, inside of the house. And you need to simplify your square roots. So we're going to break this 32 into something times something when we have a perfect square, which is 16 times 2. And the square root of 16 is 4. Now, remember, decimals are not allowed. You have to give me an exact answer. So if you try to do a square root of 32, it will give you a decimal. There's no way for you to fix it on the calculator. There's no way. So what you need to do is have these memorized. If you are in my class, you need to make sure to refer to your memorization sheet where it has all of these written out for you. Okay. In class, this is what we did. Point of intersection was not provided for you. You do need to know how to use the perpendicular slope to find where your point of intersection is. Okay, moving on to the next one. Find the distance of point E. So here's E. And point, or I guess line, FH. Line FH is this one right here. Let me make this green or orange, I guess now. Nope, still green. We know what the point of intersection is going to be. It's going to be G. How do we know that? Well, it's kind of given to us with the right angle here. So G is going to be our point of intersection. I'm still going to write out the equation and show you how to do perpendicular slope because that will be required for the test. Let me actually look ahead and see. Yeah, so I won't do it. I'm just going to go straight to the point of intersection on this one, just because I'm noticing the other questions do have the point of intersection and a line question. So we got point of intersection is with the right angle. It is 1, 2. Point here is -4 and -3. So I'm going to do x1, y1, x2, y2, writing out the distance formula. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Take the square root. Okay, let's plug in our values. We got x2 is 1, x1 is -4. Careful, double negatives here. y2 is 2, y1 is -3, and again, be careful of double negatives. All you're going to do is you're going to open and type in exactly what you see inside of your square root. Do not type in the square root. So we get 50, still has a square root, still has a radical, and still has a house. We want to split this up. Now 5 and 10 are not going to be good numbers to split this up because 5 is not a perfect root and 10 is not a perfect square root. So we want to do another split up like 25 times 2 because 25, the square root of 25 is 5. We can simplify that. And make sure you always simplify your answers when possible. Okay, moving on to the next one. Find the distance of A. Where is A? A is here. And X, Z, which is this line here, Z and X. And again, they are already giving us the point of intersection because we see the 90-degree angle. So here is your 90 degrees, here's your line, here's your point of intersection. So all we need to do is now just find the distance for this one. Distance is equal to the big square root, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Take the square root. We're going to plug this in. x2. Oh, I didn't even label my points. I was confused for a moment. Here's x1, y1, x2, y2. So y, just kidding, x2 is 0. x1 is 3, y2 is 1, and y1 is 0. Okay, typing that in. Open. We got 0 minus 3. Close it, square it, plus open 1 minus 0, close it, square it. We get 10. Now again, 10 is one of those numbers that we can split up as 5 times 2. And that's the only way, or 10 times 1, but either of them cannot be simplified, so your answer is just going to stay as the square root of 10. All right, let's go ahead and actually do the way that we did it in class. You're going to start off by, obviously you have a point and a line, so we're going to graph this. Point is going to be 6 and 4. 6, 1, 2, that's negative. So 1, 2, 3, 4, we want it positive here. That's going to be your given point. I'm going to label this G for given. Here, we want to identify slope. That's going to be important. And we have a positive slope of 1 over 1. And here's going to be our y-intercept of 0 and 4. The y-intercept is just your start. Has nothing to do with actually solving for distance. So please do not use this to solve for distance. So 4 is going to be our start. We're going to go up 1 over 1, up 1 over 1, up 1 over 1. Do not connect to the other G. We're just creating a line. And yes, you want to do all of these extra points. Using a ruler, go ahead and connect all of these, and you want your line to be a little bit on the extra side because we are going to be trying to find a point of intersection between G and our line. Now this point of intersection comes from your perpendicular slope. So this slope we're going to take and we're going to create two things: opposite, which is plus minus, and then plus minus, and reciprocal. So we're going to flip it. So for our perpendicular slope, we're going to have a negative 1 over 1. Now it doesn't look like I flipped my fraction, but I did. Let's say this was orange. This is now orange on the bottom. Let's say this one was green on the bottom. Green is now on top. So you do need to flip your fraction. This perpendicular slope, you're going to use from your given point to find the connection with your line. So I'm going to go down 1 over 1, down 1 over 1. Notice how I'm going away from my line. So I'm going to follow that pattern and go and connect the point. Found my point of intersection. Okay. Anything past your given, we don't want. So we're going to erase this because we only want this little tiny section to find the distance. We don't want the distance with an arrow because that's just infinity. We just want this little tiny segment that we've created for the distance. Let's find the point of intersection. I'm going to drag it down for my x value. That's 3. And I'm going to drag over for my y value of 7. So after you find your point of intersection, we're going to find distance. Given to us was 6, 4. Point of intersection was 3, 7. Label your point and let's find the distance. x1, y1, x2, y2. Oops, you did not see that. Let's go ahead and bring that out. Distance, x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Take the square root. x2 is 3. x1 is 6, y2 is 7, y1 is 4. Let's pick up a calculator, start typing this in. 3 minus 6, close it, square it. Plus open 7 minus 4, close it, square it. And we get 18. We make sure to simplify it. So we do need to split this up. This is the square root of 9 times the square root of 2. Everything has a house, okay? Don't remove any sort of houses until you change how it looks. So the square root of 9 is going to change into just 3. And we have our answer for our distance. Okay, let's move on. Let's do the same thing for B. Here we have our slope. And our slope is negative 2 over 1. Here we have our start, our y-intercept, which is 0, 1. Remember, the start y-intercept just tells us where our starting point is. The slope is going to tell us the rise over run. So we go down 2 to the right 1. So 2 down 1 right, 2 down 1 right, And we keep going. We want to do a little bit more on the extra points. Once we run out of space in one direction, we're going to go ahead and follow that pattern on the other side. Using a ruler, you're going to connect. Make sure your line is a bit on the extra side. And we're going to use the given point to find the -4 and 1, 2, 3, 4. Label your given point. I'm going to label it G. Okay, we're going to pick up this slope and we're going to create a perpendicular slope. Perpendicular has two things. We want opposite, so now it's going to become positive. We want reciprocal, so we're going to flip it, and now we get a positive 1/2 for perpendicular slope. We're going to use that positive 1/2 to go up now and to the right 2, up to the right 2, to create this right here point of intersection. This point of intersection, drag it down, was at -2, drag it over, and 5. Labeling our 2 points. We have our given point at -4, 4. We have our point of intersection at -2, 5. We need to label our points as x1, y1, x2, y2, and writing out our distance formula, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So x2, x1, y2, y1. Let's plug in our numbers. x2 is -5, x1 is -4, and we got y2 is 5, and y1 is 4. Open -2 minus -4. Careful about the double negatives. Square it. Let's see if I can remove that. Then we got open, oops, just kidding, plus open 5 minus 4, close it, square it, and we get square root of 5. Now remember, there are going to be some values at your square root that cannot be simplified. 5 is going to be one of them. Please refer to the memorization table that I presented to you with all of your square roots. Okay, moving on. Find the distance between the parallel lines. So when we're finding the distance between the parallel lines, it's very similar to that of what we just did. And that includes your perpendicular things. Now, this question right here is a little bit it's a little bit on the weirder side. And I want to say that just because these are horizontal lines. It's almost misleading because this doesn't always happen. But because these are horizontal lines, we can go ahead and simply just draw a line. This will not happen on the other one. Please don't think this is always going to happen. But we can find any point, right? Let's choose this one. And to create a 90-degree angle, we're going to drag. Please do not think this always happens. It does not always happen. So point number 1 ends up being at -3 and 3. Point number 2, that ends up being at -3 and -4. Once you get point 1 and point 2, this does not always happen. Please do not do this on the exam. The next question is a better representation. So if you wanted to put a note for yourself, this does not always happen, please do that. Let's go ahead and label our point x1, y1, x2, y2, and let's find the distance between them. So x2 minus x1 quantity squared plus y2 minus y1 quantity squared. x2 -3, x1 is -3, y2 is -4, y1 is 3. Okay, let's type that in. -3 minus -3, square it, plus -4 minus 3, close it, square it, and I get square root of 49. Again, make sure you have the square root, the house does not disappear, and square root of 49 is 7. Okay, that does not always happen. Let's actually do B, and B is the one that's going to be more like the test. So if you want to put a little star here, this is definitely going to be more like the test. Make sure you know how to do this. All right, step number 1, you're going to graph both lines. Do one at a time. The way that I recommended you do it in class is to separate these out as a table, so that way you can identify slope. We get a positive 4 over 1, and your start at 0 and 9 here. So let's do one at a time. I'm going to try to color code it for you. So we get 9 as our start. Then we're going to go up. So notice how I don't have space to go up 4. We're going to guesstimate 1, 2, 3, 4, 1, something right here. And now I know the pattern. So now I can go down 1, 2, 3, 4, knowing that I need to go to the left. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. And that's it. Let's go ahead and connect for our first line. You can use that outer one, that's fine. Here. So this one was our pink. For our next one, again, slope is going to be the same for parallel lines. And we have a different start at -8. Now remember, these starts, these are not anything that we're going to use to find the distance. This is just literally us finding this number on the y-axis. I am going to go up 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. Now these lines should never touch and should never cross. So if it does look like 1, 2, 3, 4, that there's going to be some sort of intersection between these two lines, double check your start and your slope to make sure that you didn't accidentally make a mistake. They should never touch, never cross. And this one was blue. Okay, after that, you're going to pick up your slopes. It doesn't matter which one, because for parallel lines, these are going to be the same. And you're going to create a perpendicular slope to that of what you have. So perpendicular slope for us is going to be opposite, so negative, reciprocal, flip the fraction, 1/4. You're going to pick a random point on one of the random lines. So I'm going to randomly choose pink. And on this pink line, I'm going to randomly choose 1, 2, 3, 4, 5, I don't know, here. So this one is my closest one. I'm going to label it R for random. And that random point ended up being at 0 and 9. Okay? Now, the second point cannot be random. Second point cannot be random. You have to use your perpendicular slope from your random point. Now, your random point could have been down at the bottom. Doesn't matter. To go down 1 and to the right 4 to create your point of intersection. So down 1, 1, 2, 3, 4. Oh, there it is. And that's going to be point number 2. We need to connect. Do not go past your parallel lines. We just want a little bitty section here that we're going to find the distance of. Now, when you connect these, they're always going to give you a 90-degree angle on both. Okay? So point number 2 is now at 4 and 8. So let's go ahead and find the distance between our random point number 1 which was at 0 and 9, and then our point of intersection, point number 2. And that was at 4, 8. Let's write our distance formula. Hopefully by now you have this memorized. And let's plug in our values. So this is x1, y1, x2, y2. So we get 4, 0, 8, and 9. Type that into the calculator. Open 4 minus 0, 0, close it, square it, plus. Open 8 minus 9, close it, square it, and we get 17. Again, sometimes we can simplify square roots, sometimes they cannot. The only factors, the only multipliers of 17 are 1 and 17. Both are prime and we can't, well, one's technically not prime, but we are having 17 as a prime number, so we cannot simplify 17. Keep it in the house, keep it in the square roots. Okay, Down here at the bottom, do not forget to study your Chapter 10 and your Chapter 9 proofs. So all of these questions that we did, these are not the only questions that are going to be on your exam. Please make sure to review. There's going to be 10 proofs on Chapter 10. And in Chapter 9, we have 13 proofs. So we have a total, let's do some math, 23 proofs that you need to know for this upcoming exam. Okay, so make sure that you study all of them. Thank you so much for watching. Take care. Bye.